Hello there, welcome to College Algebra section 2.4. My name is Gregory Carlson, and today we're going to be talking about lines. And lines are one of the easier graphs out there, and you should have learned all of this, or at least most of it, in a previous math class. And so if not, or if you don't remember it, let's refresh it really quickly. So remember that a line has a general form, and the general form for the equation of a line is mx plus b. A line has a starting point, which is called the y-intercept, and then every time x increases by 1, the line increases by whatever m is. So if m is positive, the line is going up. If m is negative, the slope and the line are going down, because every time x goes up by 1, we're decreasing by this amount. So m is the slope of the line. The closer m, the bigger m is, the steeper our line, and the closer m is to 0, the flatter our line. Also, the point 0b is the y-intercept of the line. I like to think of that as our starting point. That is where the line crosses the y-axis. So it's really easy to tell when that happens because of the b right there. So let's look at this first question. What is a graph of a function whose graph has a y-intercept of 0, 4? Well, there's lots of possibilities, actually. Basically, what they're asking is for a line that crosses through the point 0, 4, which is right here. So here's a line that does that. Here's a line that does that. Here's a line that does that. In fact, there's an infinite number of lines that cross through the point 0, 4. So let's write a few of those equations down. One example would be y equals 2x plus 4. There's an example of a line. It really doesn't matter what our slope is, because as long as we're going through the y-intercept of 0, 4, and this number is a 4, any answer will work. So here's another one, y equals 2/3 x plus 4. And here's another one, y equals negative 5x plus 4. Slope doesn't matter as long as we're going through the point 0, 4. What's an example of a function that is a constant function? Well, a function that's a constant function looks like this. It's a function that's not going up or down ever. And an example of a constant function is, you can see that x is changing, but y never changes. And so a horizontal line has an equation of y equals something. So if this line was going through the point 0, 3, the equation of that line would be y equals 3, and we wouldn't have any x's. Another example of a horizontal line would be y equals negative 2, or y equals 57. If it's a horizontal constant function, that means y just equals the constant number, and you'll notice that every value in our domain is getting mapped to the same output. So that's what a constant function is, and it is a function because it passes the vertical line test. Write some examples of functions that travel through the origin, or in other words, that have the origin as a point. This is kind of similar to this problem we did. There's lots of equations, lots of lines that go through the origin. So basically, we just need our y-intercept to be 0, 0, which means that b is 0. So an example of a line that goes through the middle, that goes through the origin, would be y equals 3x, or y equals negative 7x, or y equals 11 over 4x. Because each of these lines have no y-intercept, they're all going through the origin. b equals 0. In fact, if you wanted to, you could write plus 0, but that's unnecessary. But that makes it easier to see that the b is 0. So hopefully this is starting to refresh your memory of earlier algebra classes. Let's push ahead to page 22. When does a line have an undefined slope? Remember that an undefined slope is a vertical slope. Hopefully you already knew that. A constant slope is horizontal. A vertical slope is an undefined slope. And so that's when we just have an x value. X equals 2 is an example. x equals -5 is an example, and x equals 13 is an example. So if it's just x equals, that's a vertical line. If it's just y equals, that's a horizontal line. And notice that if we do have a vertical line, this is not a function because it doesn't pass the vertical line test. I can draw the line that touches the graph in more than one place. So something being not a function and undefined are kind of sort of related because if you do have an undefined slope in your graph at any point, then that means it also won't be a function. Okay, so here we go. Let's do the next one. Graph the following function and give the domain and give the range. So f of x is equal to -2. Remember, f of x is just the name of the function. It's not f times x, it's f of x. And if it helps, just replace f of x with a y. Because they mean the same thing. F of x equals -2 means the same thing as y equals -2. And if it's y equals, then that means it's a horizontal line going through the value -2. This is a function because it passes the vertical line test. So, state the domain and the range. The domain of this function is going to be all real numbers because we can plug in any value for x. So you could write all real numbers like this. That's a little shaky. I don't know if I would write it like that. You could write that the domain are the words all real numbers. But that is also not how the homework is going to want you to put in the answer. The homework wants an interval. So remember that the domain in interval notation is -∞ to infinity with parentheses. So the domain is all real numbers. What about the range? Well, the range is a little bit tricky, actually. What values of y exist? In fact, there's only one value of y that exists, and that only output is -2. Every single one of our inputs goes to -2. So the range is actually only the point y equals -2. Notice I said y equals. Domain is x, range is y. Domain is x, range is y. So the way you would write only that value in interval notation is like this. Or no, that's not right. Well, here's how you would do it. You would write a bracket and -2 in a bracket. The only value in interval notation is -2. I guess if you wanted to, you could write this, but this is a little goofy. Writing it in interval notation. I don't know. Hopefully there will be a way for you to put in the range for this. The range is the only value y equals -2. I have time to do one more. Let's graph this. -2x plus 3y equals 6. The way we graph this line, and again, hopefully this is review, the way we graph this line is by putting it in Y-intercept form, and so that means solve for y. So first we add the 2x over. So 3y is equal to, I'm going to put the x term first. Remember that 2x plus 6 is just 2x plus 6. Don't try to do anything fancy there. Then we divide by 3, and we divide everything by 3. So y is equal to 2/3 plus 2. There's the equation of our line right there. Y equals 2/3, whoops, I left out my x. 2/3 x plus 2. The slope is 2/3. And the y-intercept is 2, so that means the graph goes through the point 2, 0, 2. So here's our y-intercept on the x-axis at +2. And then from this point right here, we move, every time we move by x1, we move with our slope. So slope is rise over run. So if we go over 1, we go up 2/3. That's a little confusing, so instead you can go up 2 over 3, up 2 over 3, and that's the same result. So up 2 over 3, up 2 over 3, up 2 over 3. Or you can go reverse both of those directions, down 2 over 3, down 2 over 3. If this slope had been negative, our line would have been falling. as we move to the right. So there's our increasing line. And remember, all of the points on this line are the solutions to the equation negative 2x plus 3y equals 6. That's what this means. As you can see from this line, what is the domain in the range? For every value of x, there is graph, and for every value of y, there is graph. So the domain and the range of this are both all real numbers. For the domain, x is all real numbers, and for the range, y is all real numbers. In fact, that will always be the case for a line if it's not horizontal and if it's not vertical. I am over 10 minutes, and so let's stop here, and in part 2, we will look at the slope formula. So see you then.